Kubernetes with Thomas Vitale.
The Azure DevOps Podcast is a show for developers and DevOps professionals shipping software using Microsoft technologies. Each show brings you hard-hitting interviews with industry experts, innovating better methods, and sharing success stories. Listen on to learn how to increase quality, ship quickly, and operate well. And now your host, Jeffrey Palermo.
Before we start, I want to put out a personal message. For those of you who have followed my work and content for some time, you know that I started ClearMeasure 10 years ago. We're a software architecture company, and that's the type of consulting we do to help in-house teams be great, to jumpstart them along their way. So all of our work is programming in all of its various forms, and we've done a tremendous amount of DevOps and cloud automation work as well. And we're the North American consulting partner for Octopus Deploy. Now, I haven't done this very often, but I'm putting out a call for anyone who'd like to work with me. We've been running on a backlog of projects for quite a while now, and we need to grow. We need some more .NET software engineers, DevOps engineers who have Octopus Deploy experience and Microsoft Cloud experience, and we're also in need of a few more experienced software architects. And if you followed me for any length of time, you probably understand how I think about software. And if you like the way I think about it, then you'll absolutely love working with me at ClearMeasure. We need to hire some people pretty immediately. So if this has piqued your attention, please go ahead and apply online on the website. And if you have any questions, just send me an email at Jeffrey, Jeffrey, at clear-measure.com. And thank you for indulging me with the interruption. And here's our regularly scheduled episode. Welcome to the show. I'm Jeffrey Palermo, your host for helping you and your teams move fast and deliver quality and to run your software with confidence in Azure, and all while using everything that the .NET ecosystem has to offer. This podcast is sponsored by ClearMeasure, a software architecture company that empowers .NET teams to be self-sufficient and able to deliver world-class results through its ClearMeasure Way methodology. I like to keep announcing that my architect forums are going strong. Signups for the next session are up. And if you lead a software team and are looking to collaborate with peer architect leaders, you can just sign up at the link in the show notes. And for those of you who are looking for the Programming with Palermo show, that's my video podcast, just search in any of the directories and you'll be able to find it as well as on YouTube. My guest today on the show is Thomas Vitale. He is a software engineer and architect specializing in building cloud-native, resilient, and secure enterprise applications. He designs and develops software solutions at Systematic, that's in Denmark, where he's been working on modernizing platforms and applications for the cloud-native world, focusing on developer experience and security. And he's also an author of the book from Manning, Cloud Native Spring in Action. Thomas, welcome to the show. How are you, sir?
Thank you very much, Jeffrey. Thanks for having me.
Oh, my pleasure.
It's a pleasure to be here.
Awesome. Congratulations on the book. And before we get into what you kind of spend your time thinking about, go back in time for us and for the listeners. What are some of the major milestones along your journey that kind of led you into working on what you're working on today, software-wise?
Yes, that's an interesting question. I guess it started some years ago at the university. I studied computer engineering and software engineering. And from there, I started focusing a lot on software application development, in particular in the Java ecosystem. That's how I started working with Spring, which is the framework used and covered in my book. Mm-hmm. And from there, I started being interested in the whole cloud-native world, about technologies, not only the application point of view, but also the platform side. So how to support application developers in delivering value to their customers and their users. So from there, what I've been doing recently is kind of juggling between these two points of view, the point of view of the developers and application development and being productive, delivering value effectively to customers and end users of our software, but also at the same time, the platform point of view. So how to support that work, how to provide a great developer experience, making sure that security is in place, and overall, how to collaborate across different roles, different people in a project. to deliver the best product possible. Yeah.
Yeah. Oh, that's so important. Getting all the people organized so that everyone's aligned. Yeah, for sure. Will you tell us a little bit about the book? Starting, when did you actually decide, you know what? I need to write this book.
Yeah, so that was an unexpected decision, to be honest. So I've been working on with Java and the Spring Boot framework for several years, also contributing to some of the projects. I'm really a big supporter of open source, so I always try to contribute to different open source projects. Spring Boot was one of that. I was writing some articles about it and be out there in the community talking about this topic. And then the publisher reached out to me, so you're talking about these topics, but maybe you have an idea for a book. And I actually did have one, and it was the cloud native point of view in application development that was really missing, I felt, because I was working in that area and I couldn't find a book covering application development with Java and Spring Boot for based on cloud native architectures, cloud native patterns. That's how I started. So I planned the book. It was the beginning of the pandemic, so the beginning of COVID. So I thought, okay, it might be interesting to have a project since I'm at home for this period. And 2.5 years later, the book was done.
Oh, fantastic.
A bit longer than expected, but it was such an interesting experience. Yeah.
Sure. Awesome. Well, you did something really, really productive with the extra time. Now, some of the listeners might be asking, okay, hey, don't we all talk about Microsoft technologies all the time? What do you mean, Java and Spring Boot? But Kubernetes is this intersection point that's kind of bringing together different technologies in different parts of the industry that sometimes have a kind of a wall between them. There's development teams that use Java and that kind of pushes them to some set of technologies, or they use C# and that pushes them to another set of technologies. But it seems like the whole industry has embraced Kubernetes. It seems to be this common technology that is becoming ingrained with the concept of cloud native and containers and all. So can you help us understand that, and let's go over the basics of Kubernetes. Since you've gotten so deep into it, can you define for the people who really have never used Kubernetes before, regardless of technology, how do you think about Kubernetes?
So I would probably start by talking about containers, because that was kind of the starting point. So we started realizing that we needed some better ways of packaging and delivering our applications. And as you mentioned, we might have different technologies, different languages, different frameworks that we use in our applications. But if we put them all in a standard packaging format like a container, then it becomes easier from an operational perspective to deal with a very different system with different languages, with different frameworks. And that kind of was an enabler for the whole microservices movement, because once we start having multiple applications in our system or in a distributed system, we need a way to manage all those services. And having all containers, all applications having the same shape from the outside really helped. But then we ran into an issue that we had too many containers. So what about scalability, for example? What about orchestration of all these containers? If in a production scenario, I want to have high availability, for example, so I'm going to have multiple virtual machines. So how can I juggle all these containers? How can I distribute these containers across these virtual machines to be sure that my service is always available to my users? So with minimal disruption. What happens if one container goes down? Should I go there and just start it up manually? That doesn't really scale. It might work with virtual machines, but when you have hundreds of containers, that doesn't work. And that's where Kubernetes comes in, because the basic feature of Kubernetes was container orchestration. So we ask the Kubernetes service that we want to deploy a certain application as a container, and then Kubernetes takes care of scaling that container across different virtual machines. And very importantly, it deals with self-healing. So if a container goes down, if it fails, if it enters into a faulty state, then Kubernetes itself can bring it up for us so that the service is always available for the users. But then that was the basic functionality. But at that time, there were other orchestration systems. I think one of the most important features of Kubernetes that then made it so popular and so famous, and now it's defined like the operating system of the cloud, basically, is its API model, because it's not just doing orchestration, but it provides a standard API model that you can use to work with containers and do the application deployment set of operations, but actually provides a model to to operate and to monitor, to manage any kind of service we might imagine, because it provides this standard API, so it's super flexible and extensible. So from Kubernetes, I can manage containers running within Kubernetes, but for example, using a tool like Crossplane, I can spin up services on Azure. So I use my Kubernetes service as kind of a universal control plane. And then using this standard API, I can use the same tools, the same format, the same approach, both to run my application and services in the Kubernetes cluster, but also run and manage services outside my cluster. For example, in the cloud, and spin up an Azure DB or even an Azure Kubernetes service. But then I have this central point where I can really streamline all my operations and management, because then any kind of service can be abstracted through this common API that Kubernetes provides.
Mm-hmm. Okay. Well, let's drill down and just I want to get your take on these different concepts. We've had, you have the concept of the data center, which is massive, and within a data center you have different rows of cabinets, and but then in the logical sense, we're used to server clusters and database clusters, and within you can have multiple databases, and within each server cluster you could have one web farm, for example, or multiple web farms in a server cluster. When we think of a Kubernetes cluster, how do we know when we need more than one Kubernetes cluster?
Yeah, that's a very interesting question. And I guess the general answer would be it depends. So diving a bit deeper into that, one point of view that comes to mind as the first one is security.
Mm-hmm.
What is the usage? What is the purpose of a cluster? So if I'm using a cluster for development, then I can share the cluster between developers. So Kubernetes has this namespace concept, so I can isolate the workloads between different developers. It's not a very strict isolation because it's within the same cluster, but it's good enough for development purpose. But then when you go in production, we need to enable multi-tenancy. That's one of the features of Kubernetes. But then based on the requirements, we might want to have different clusters rather than sharing the same cluster across different customers. And that's not a new problem. We had this problem like the traditional hosting services for websites, for example. You can get a shared hosting service, or you can get a dedicated one. So it really depends. If for industries like bank or healthcare products, perhaps you really want your own cluster, which is very much isolated from everything else. But perhaps in a staging environment where there's no production data, there's no sensitive data, so the security threat model is a bit different, then it might be fine to share. And then we have also some kind of hybrid in between, virtual clusters, because of course we can always add more abstractions and virtualize everything. So that's, for example, a project called vCluster, where inside one, let's call it physical cluster, we can have multiple virtual clusters. And that provides a better security compared to namespaces, but also less compared to having multiple clusters. So it really depends on the use case. It's very flexible in that way.
Okay. And so with a Kubernetes cluster, is it always, say, more than one computer, or for testing purposes, is it common just to set up a Kubernetes cluster on your own computer, or is that a thing anybody even does?
I think it's a common thing to do, especially at the beginning when experimenting. It's very easy to spin up a cluster. Let's call it a cluster on your local machine, which maybe runs as a single virtual machine or as a single container. So we have this inception where we can run a Kubernetes cluster inside one single container. That's a way to do it. But also we are starting to see more and more use cases at the edge of systems where we run Kubernetes at the edge. So there are several projects recently that have been announced dealing with these specific use cases where we need a very lightweight Kubernetes installation for these devices at the edge of the system. So running on IoT devices.
Right.
That's also a quite interesting use case for Kubernetes. So it doesn't have to be multiple clusters, like multiple virtual machines or multiple nodes. So we also have these quite interesting use cases in specific areas of our domains.
Just to have a standard deployment model.
Yes.
Okay. And
again, it's that standardization of the API and the whole management operation side of things that can really help bootstrap projects quickly and reduce time to market and get out there, because there's this wide variety of tools and processes that we can use, all working towards this standard interface.
Okay. Well, break down, when you have a Kubernetes installation, break down, what are the building blocks? Even before you've installed any of your own containers for it to run, what do you have when you install it? What are the piece parts and how do they work?
So when talking about Kubernetes, we can distinguish between the control plane and the data plane. So the control plane is basically the group of applications that provides all the services that we look into a Kubernetes cluster. So the main important parts of that is probably the API server. So it's the application that receives all the API requests. The request being, please deploy this application for me, or please expose this application through the load balancer, that kind of request. And then we have a component, which is by default a distributed database, etcd. That's where the state is stored. So we need a place to store what we ask Kubernetes to do. So if we ask to please deploy 3 replicas of my application, we need that state stored somewhere. And then we have the components that take care of figuring out across the cluster. So on the machines where we have the computing power, where to deploy these applications. So they check for, is there enough CPU and memory? Then let me schedule the deployment of a container in that machine. And then if that machine goes down, then, okay, so let's find another machine. Let's spin up a new application instance in that other machine or node. And that's the data plane where we run all our applications, all controlled by these main components that take care of processing requests and making sure that what we ask Kubernetes to do, that is what we call the desired state, is what happens in the cluster. So we call it desired state. So Kubernetes is basically implementing a control loop that continuously check for what we ask to do, actual state, the desired state, and then make sure that that state is always what is happening in Kubernetes. And if there's any divergence, then it takes the necessary actions in order to ensure that we get there eventually. So we have this eventual consistency point of view.
So if one of our applications goes unresponsive and it says, hey, I'm supposed to have 4 of these running and I can only see 3 of them because the 4 of has just gone the zombie process, it'll kill and restart a new instance?
Yes, exactly. To ensure that we always have 4. Yeah.
Many thanks to our podcast sponsor, ClearMeasure. ClearMeasure is a software architecture company that empowers clients' development teams to be self-sufficient, moving fast, delivering quality, and running their systems with confidence. Whether starting a new project or developing new technologies or techniques, ClearMeasure sets up your team to deliver world-class results. Learn more at www.clearmeasure.com. ClearMeasure, empowering software delivery. ClearMeasure is also happy to be a sponsor of the video podcast, Programming with Palermo. Watch, learn, and program alongside Chief Architect Jeffrey Palermo. Videos are added weekly and available on syndicated locations supporting video podcast or by visiting palermo.network. Tune in today.
So you said another keyword, a node. And then from other listeners, I've heard the term pod before. How do all those fit together? You get this concept of a cluster and then node. What's a pod and how do all those relate?
Yes. So a node is the entity providing the computing power to run our application. So it could be a virtual machine it could be bare metal, or it could even be a container where inside we run other containers. So that's the general definition of a node in Kubernetes. Then I started this explanation by saying that the starting point was containers.
Mm-hmm.
So one of the problems with containers was that we needed a way, or maybe a different abstraction, so that we didn't have to care about managing the single containers ourselves. So Kubernetes provides this concept of a pod. A pod is the smallest entity in Kubernetes, and inside the pod, we have our application container. So with Kubernetes, we don't work with containers directly, but with pod. Inside the pod, we have at least one container, which is our application, but we can have more containers that can do some specific jobs. For example, we might have a container that scrapes the application logs and do something with them, or a container that intercepts all HTTP traffic and make sure that outside is exposed via TLS or MTLS between services. So we can have, register some metrics to achieve more observability. So we can have all these they're called sidecars, if we use these additional containers to do these specific jobs. But at least we need one, which is our application. And then Kubernetes takes our instructions and deploys the number of pods necessary to fulfill our request. So if I ask for 4 replicas of my application, I would get 4 pods deployed. Yeah.
So if I had a website, I wanted 2 instances of the site to have a 2-node web farm, and then I have a backend job that's processing messages from a queue, then it sounds like I would have 3 pods in that case?
Yeah.
Or would I have 2 pods?
2 pods for the website.
Okay.
Yeah, and 1 pod for the job, perhaps, that continuously do something with the message queue.
Gotcha.
Perhaps.
Okay.
And then again, that's what the desired state. But then the actual state might temporarily be different. For example, if a node goes down, so we might have these little time windows where we might have only 1 replica because the second one just died. So it had to be restarted by Kubernetes.
Okay.
And that happens automatically.
Yeah. Now, with large decomposed systems, it's always been common that different applications be configured with maybe web service addresses or the address of where to drop a generated PDF file and all this different configuration about where is this other place. And in a situation where you might have multiple nodes on different virtual machines who have different IP addresses, and a node goes down and pods are moved wherever, how does the application know if the application is developed to have a web service address and know where to go? How does it know when Kubernetes might move one container to a pod that happens to be on a different virtual machine with a different IP address?
Yeah, Kubernetes offers out of the box a service discovery functionality. So we never talk directly with a pod usually, but we talk to another object, which is called a service. We can think of a service as kind of a load balancer in front of all the pods that replicate my application. So the service would have a DNS-like name, so like my website.com, and then within Kubernetes, that request sent to the service is forwarded to one of the available pods at that time. So we never need to worry about the specific pod IP address or where it's located in my system. So the service has a consistent IP address, so we can do some real DNS resolving there because the service will always be there. But the pods are volatile, are ephemeral, so that they can keep changing. So we need this entity in between. So we have a fixed long-term interface we can always call, and then Kubernetes does the rest by forwarding the request to the specific pod.
Okay.
And this is quite nice that comes out of the box, so we can just call the service DNS name, and then one of the replica will reply.
So when you're doing development locally, do you use local DNS on your own computer just so that you're developing in that way? Or what does that look like?
Yeah, so we have two layers there. We have, if we talk inside the cluster, then it's not really a problem because the cluster will have a local DNS service.
Mm-hmm.
So if my application is to call the database and they're both running in Kubernetes, then it will be the same whether I'm working locally on my local cluster or in production, because it's all internally done within the cluster, this name resolving. A different case is for the applications that are actually exposed outside the clusters, which are the ones that the end users need to access the applications. So in that case, we need something else, because by default, Kubernetes doesn't contain an external load balancer. So we usually rely on a load balancer service provided by a cloud platform. If I'm using the Kubernetes service on Azure, if I want to expose my application, I declare that I want to expose this application outside the cluster, and then I get automatically provisioned a load balancer in Azure that exposes a public IP address, and I can use that IP address directly, or I can even use a DNS service that resolves to that IP address. Of course, locally that's not possible, so it depends on the setup. If we are using a remote development environment, we might have access to this DNS functionality. So it would work just like in production. Otherwise, we can do a port forwarding job. And in some of the Kubernetes distributions that are usually adopted in a local environment, provide some convenient features to do that out of the box. For example, using a tool called Kind, I can run Kubernetes in containers, and then I can access the services through localhost port 80, for example. The ingress point of the cluster is that, so I don't need to do port forwarding explicitly myself.
Okay.
But yeah, we need some tweaks when we work locally because we are missing that load balancer component.
Gotcha. Now, there's so much has changed in the nature of containers. It used to be, everything was Docker, Docker, Docker. Sort out some of these. Where does Docker Swarm fit in? Where does Helm fit in? And any others? Just can you demystify those concepts for us?
Yes. So if we talk about Docker, the open source project, Docker is still relevant. Actually, the format used by Docker for building container images is what has been standardized by the Open Containers Initiative. So it's what we call an OCI image. It's basically the Docker image that has been standardized. So now, even if we use different containerization technologies like Podman, we are still working with OCI image. So if I build an image with Docker, then I can run it in Podman because it's the same standard. In the same way, we got standards for how to distribute OCI images. So we are not forced to use specific tools. And we got also standards about how to publish those images. So right now the landscape contains a few different options for running containers. I mentioned Docker and Podman. Then you mentioned Docker Swarm. Well, Docker Swarm was an add-on, I would say, on top of Docker that solves some of the issues regarding container orchestration and, for example, scaling containers. And well, nowadays, I don't know how much it's used, to be honest. Like Kubernetes really became the primary choice. There were a few options back then, and Kubernetes really was the one that is still here. I don't know how much development Docker Swarm is.
Okay, so those two are competitors. You would not use them together. They're either or.
Yes.
Okay.
And I'd like to specify there that it's not the same set of features. So some of the container orchestration features are provided in Docker Swarm, but for more complex scenarios or for all the other things I mentioned, like the API model and this concept of universal control plane, that's something that is really specific to Kubernetes and is what also concur in determining its popularity.
Okay.
But yeah, you would use either or.
Gotcha.
If you're looking for container orchestration. Yes.
And how does Helm relate?
Helm.
Yes.
Yes. So we started with Kubernetes. We solved the problem of container orchestration and scaling. We had this very nice format, the container, the OCI format, standard one, to package any kind of application. So it doesn't matter if it's Python, Java, .NET, it looks the same from the outside. But then we found out, okay, now we have the standard API, we have standard ways of configuring the applications, but then how do we package the configuration?
Mm-hmm.
Because it's not enough that I get access to a container image. I also need all the different configuration in order to run it on Kubernetes. And Kubernetes has quite low-level APIs for that, for like the pods, the services. So from a consumer point of view, it's not the best thing. Like we would like some abstraction on top of that. And Helm was one of the first tools to provide a solution to that. So what Helm does is offering what is called a Helm chart. It's a package that contains all the configuration files to deploy specific applications on Kubernetes. And it works like on a package manager for an operating system from APT or Homebrew, where I can install like a database on my local computer in my operating system. It works in the same way, but for Kubernetes.
Now, you said it's one of them. Does that mean, do you use Helm, or are there a number of these solutions like that?
Yeah, Helm was one of the first one that really solved this problem and became very, very popular. So it's very common to find third-party products out there that also offer a Helm chart, which makes it really easy to install. But since then, we got different projects and different tools to solve the same problem, but in different ways.
Okay.
And to solve maybe some challenges that Helm has, because it's based on some templating, which can be quite complicated to write and maintain. So there are other tools that, depending on the use case, there are other options. But it's definitely the one that became more popular. So for third parties out there, it's very likely that you can find some Helm chart.
Okay.
So just to give a small example, like I need a database, I can run Helm install, the name of the database, and if I configure a certain repository where I can find these Helm packages, then I can install it, and I don't have to worry about writing all these configuration files for Kubernetes.
Right.
Maybe providing a few parameters. Yeah.
Do you like to use Helm, or do you use something else to solve that problem?
I also use Helm in particular because some third parties I use in the open source space, that's what they use to distribute their products and configuration. But for first-party applications, so the applications and services I work with, I prefer other formats. In particular, I really like working with a tool called Carvel. It's a CNCF sandbox project, and it provides different tools, very Linux style. You can combine them or use only the ones you need. And Carvel provides a quite nice packaging format to put together configuration containers and to distribute them. So that's the primary technology I use. I'm also part of the community and contribute to the project. Just as a disclaimer.
Yeah, absolutely. No, please promote it. You're involved with the open source project.
Yeah, it's a great project. That's how I got involved, because I was using it and it was really convenient for me to use and really nice. So I joined the community and started giving back because I really believe in this project. Yeah.
This episode has been jam-packed with information. As we kind of close up our time here, you mentioned being able to install Kubernetes locally and work with it, or even install it as a container. What is your favorite method for spinning up your own Kubernetes cluster locally? Do you create a VM locally on your computer or your test lab, or do you use the container version? What's your favorite at the moment?
So in general, I like using a couple of tools. If I need a simple cluster like Kind or K3S or Minikube, but for something more, like if I'm working on applications or on services that run on top of Kubernetes, I prefer something more than just a simple cluster, because on top of the cluster, I would need things like the ingress configuration with the whole load balancing and DNS strategy. I would need some databases, perhaps some services to scale more efficiently my deployments. And that's basically what we call a platform. Now, that's a very, it's a buzzword perhaps. Nowadays, a cloud-native platform that we build on top of Kubernetes. So I actually have, based on all open source projects, we can call it a platform that I usually run when I want to focus on services on top of Kubernetes. And sometimes I use one of those local distributions, or I spin up a cluster in the cloud so I don't have to manage the cluster. But I like to have those extra services on top of it, because then I can focus on the specific problem I'm trying to solve. And that ties with the whole developer experience topic that also I'm particularly passionate about.
Okay. So for people who want to dig in more, would you recommend that they go through the effort of setting it up in a local test lab, or to just spin it up in AWS or Azure?
I think the local setup is a good starting point. Also, it's free. So you can start with installing Kind. I think Kind would be a good starting point. And then take it from there. Of course, if you have access to a cluster in the cloud, that's the best thing, especially if you're a developer, because then it's a managed service. So you don't have to worry about that and focus on the value you're building on top of the cluster. Yeah.
Awesome. Wow. Well, time flies when you're having fun talking about Kubernetes. So,
yeah.
Well, Thomas, I really appreciate you coming on the show. That's a wealth of information, fantastic explanations to kind of walk us through all the concepts. So I really, really appreciate it. Thank you.
Yeah, thank you very much. It was a pleasure.
Oh, pleasure's all mine. Pleasure's all mine. And until next time, keep shipping.
You've been listening to the Azure DevOps Podcast, a show for developers and DevOps professionals shipping software using Microsoft technologies. Go to www.azuredevops.show for show notes and other episodes. On behalf of your host, Jeffrey Palermo, and our sponsors, thanks for listening, and may God bless you.